viewers of my YouTube channel. I am extremely happy to meet you people in yet another module, Control Systems Lecture Series, Lecture 25, State Space Analysis of Mechanical Systems. This is the continuation of my last lecture, Control Systems Lecture Series, Lecture 24, State Space Analysis of Electrical Systems. There we introduced the state space representation along with obtaining the state space representation of electrical systems. In this presentation or in this video, we are going to see the state space analysis of mechanical systems. I want your feedback, comments and suggestions for betterment of my content delivery. So I have given the email ID and I have given the phone number. This is also the number that can be used for the WhatsApp. I want you people to view my videos, share my videos with the huge section of the learning community. I thank you very much for your views and earlier subscriptions. I am sure you will render the same kind of support in the future also. You will also give a good support for this video, I believe. Let me move to the presentation. So the objective, the learning objective of this presentation or this video is to obtain the state space representation of mechanical systems. In the last lecture 24, we have seen how to obtain the state space representation of electrical systems along with introducing the state variables. State space analysis of mechanical systems, how to do it with the selection of physical variables. We know that energy storing elements or energy storage elements are mass and spring in a translational mechanical system. A translational mechanical system is a system with mass, spring and dashpot. This we have already seen in our regular control systems lecture series earlier videos, wherein we have seen the mathematical modeling of the mechanical systems. So if I am right, I think that is my third video if I am right. So there I have clearly explained how to obtain the mathematical modeling of mechanical system, translational mechanical system, as well as rotational mechanical system with the help of examples. So we know a translation mechanical system can be characterized by this mathematical model. Applied force F of t equal to m into d square a by dt square plus b dy by dt plus ky, where y is the displacement, dy by dt is the velocity, d square y by dt square is the acceleration, or this is the rate of change of velocity and this is rate of change of displacement. So these two are going to decide this state space modeling. That is what I said, rate of change of displacement, rate of change of velocity are considered in the modeling used for obtaining the state space model, right? So physical variables displacement y and velocity dy by dt are chosen as state variables. So if y is the state variable, means dy by dt is the derivative of state variable, that is why dy by dt rate of change of displacement. If dy by dt is the velocity, which is another state variable, derivative of velocity is nothing but d square a by dt square, which is the acceleration. So that is another state variable's derivative. So if this is x1, this is x2, means x1 dot is this dy by dt, x2 dot, that is derivative of this, is d square a by dt square, where x1 x2 are the state variables. So the input is the applied force F of t. So output we can choose displacement and velocity. Let us understand this with the help of an example. Obtain the state model of the mechanical system given below. So we can see a mechanical system with two masses, two springs and two dashpots. So we know very well that these two masses along with these two springs are the energy storing elements. So definitely there should be four state variables, right? Other way is we can obtain a second order derivative equation for this mass, that is for this degree of freedom. We can obtain another second order derivative equation for this mass. So therefore for this mass second order means two state variables. For this second order means another two state variables. So 2 plus 2 4. So in either way, just by seeing the number of energy storing elements or by seeing the order of the system, we can decide how many state variables. So let us see how to obtain that. So for f of t, that is for mass m1, applied force f of t is balanced by, counterbalanced by these three restoring forces, Fm1 plus Fk1 plus Fp1. So what is Fm1? We know m1 d square over d square. This we have seen in that video 3, if I am right, mathematical modeling of mechanical system. So B1 is concerned with M1 and M2. Since we are referring M1, relative displacement, relative velocity is d by dt of y1 minus y2 multiplied by B1. For spring, it is K1 into y1 minus y2. So if we arrange these things as like this, that is d square over dt square terms, dy1 by dt term, dy2 by dt term, y1 term, y2 term. These things on expansion, you will get equation 1. Then for second equation, consider this mass m2, that is this degree of freedom. So there is no applied force here like this here. So 1, 2, 3, all 4, 5. 1, 2, 3, 4, 5, all are restoring forces. That is why I have written Fm2 plus Fk2 plus Fb2 plus Fk1 plus Fb1 equal to 0. So Fm2 means m2 d square by d square. Fk2 means k2 into y2, because here this is connected to fixed frame, so y2 minus 0, it's y2. So b2 into dy2 by dt minus 0, so b2 dy2 by dt plus b1 into dy2 by dt minus dy1 by dt. We know why this like this, why it is like this, all this we have discussed in that video 3. So plus k1 into y2 minus y1 equal to 0. So this again after rearranging in the form d square dt by dt square term, dy2 by dt term, y2 term, dy1 by dt term, then y1 term, you get like this equation 2. So totally there are two displacements and two velocities, and we know that there are four state variables. I have already explained why there are four state variables. Now how to choose the state variables? We know very well. If it is a single equation like this with only three elements, then y is one state variable, dy2 by dt is another state variable. Right? So this is x1, this is x2. Now y1 is there, dy1 by dt is there. Y2 is there, dy2 by dt is there. Therefore, y1 you take one state variable, y2 you take as another state variable, dy1 by dt third state variable, dy2 by dt fourth state variable, or even we can take x1 equal to y1, x2 as dy1 by dt, x3 is y2, x4 as dy2 by dt. So in what order we take is not important. All these variables should be taken. That's all as state variables. So input is f of t is u of t. Now, if you make substitution of all this into equation 1, so f of t is u of t, m1, what is d square m by dt square? dy1 by dt is x3, therefore d square m by dt square is x3 dot, therefore m1 x3 dot. b1, what is dy1 by dt? x3, b1 x3, right, minus b1 dy2 by dt. What is dy2 by dt? x4, so minus b1 x4, k1 y1, what is y1? k1 x1, minus k1 y2, what is y2? x2, that's all. Now we have to write x3 dot equation, therefore all these terms should be brought to this side and we have to divide by m1, therefore x3 dot is u of t by m1, this is minus b1 x3 by m1 plus b1 x4 by m1 minus k1 x1 by m1 plus k1 x2 by m1, that's all. Here I have written in the form x1 first, x2 first, x3 first, x4 next, and finally u, like that we have rearranged, that's all. So x3 is nothing but dy1 by dt, x3 dot is d square n by dt square. Just for the benefit of learners, it has been rewritten, that's all. Similarly, from this equation we can write m2 into, what is d square y2 by dt square? D square y2 by dt is nothing, x4 dot b1 plus b2 into, what is dy2 by dt? x4. What is y2? x2. So x2 into kn plus x2, b1 minus b1. What is d1 by dt? x3 minus b1 x3 minus k1. What is y1? x1 equal to 0. That is what we have written as equation this, that is this equation m2 x4 dot plus whatever I have said I have written. So from this I have to write x4 dot like how I have written for x3 dot from this equation. So for which I should divide through it by m2. Before that I should also bring all the terms to the right hand side. Therefore x4 dot is equal to minus x4 into b1 plus b2 by m2. That's all. Then minus x2 into k1 plus x2 by m2 plus b1 x3 by m2 plus k1 x1 by m2. So written in this form, x1 first, x2 first, x3 first, x4 next. That's all. So we have written for x3 dot and x4 dot. What is x1 dot? See, x3 is dy by 1 by dt. What is y1? x1. Therefore, what is dy by dt? x1 dot. So x1 dot is x3. x4 is taken as dy by 2 by dt. What is dy by 2 by dt? y2 is x2. Therefore, it is x2 dot. Therefore, x2 dot is x4. So x1 dot is x3, x2 dot is x4, x3 dot is that equation A, x4 dot is, that is this equation A is x3 dot, then x4 dot is equation B. So A, B, C, D written in this form, vector matrix notation. So x1 dot, x2 dot, x3 dot, x4 dot. State vector is x1, x2, x3, x4. The input is U. So coefficients of x1, x2, x3, x4 in all the four equations. In the first equation, x1 dot is equal to x3 because x1 dot x3 means 0, 0, 1, 0 because no x1 term, x2 term, x4 term. Next x2 dot equal to x4, x2 dot equal to x4 means no x1, x2, x3 term, only x4 term. Next x3 dot we have, what are x3 dot terms. So these coefficients minus k1 by m1, k1 by m1 minus b1 by m1, b1 by m1 should be written. That's all. Then 1 by m1 into u because u by m1. That's all. Next x4 dot. So x4 dot is k1 by m2 minus of k1 plus k2 by m2, b1 by m2 minus of b1 plus b2 by m2. No input term. So these four equations A, B, C, D were written in the form of state equations in vector matrix notation. So this is derivative of state vector, this is state vector, this is input, and this is system matrix A, and this is your input vector B. This we have already seen in last video, right? So what is A, what is B, all that we have seen. Only thing is we are representing A, B for the mechanical system, that's all. So the output equation is y of t equal to cx plus du. We can take the output variables as displacements, or even we can take displacements and velocities as outputs, or only velocities as outputs depending upon our quantities of interest. Suppose we take the displacements as outputs, y1 is y1, small y1, y2 is y2. That means in terms of state variables, y1 is x1, y2 is x2. Therefore, y1 is x1 only 1, 0, 0, y2 is x2 only 0, 1, 0, 0 because other state variable coefficients are 0. That's also y is equal to cx form. Suppose we take the velocities as outputs, means y1 would have become dy1 by dt, y2 would have become dy2 by dt. What is dy1 by dt? x3. What is dy2 by dt? x4. In that case, this would be 0, 0, 1, 0. This would be 0, 0, 0, 1. Or even we can take those two velocities as two more outputs. In that case, y3, y4, and whatever I have said will be appended with these two. That is, they are also added. That's all. So this is how we have to obtain the state equations and output equations for this mechanical system. So I hope I have clearly explained how to obtain the state equations and output equations from the given mechanical system just based on the mathematical modeling of mechanical system, which we have explained in our earlier video. If I am right, it is video 3. So I would like you to mention that in the next video we will see the rotational mechanical system with the help of an electromechanical system. That is, we are going to see how to obtain the state space representation of armature controlled DC motor and field controlled DC motor. So till I meet you in the next video and next module. Thank you and goodbye.